Okay, today is Wednesday. I'm going to go over all the problems on the back of the sheet. Those that came to class today, which I think I saw everybody, we had time to work on that. All right, so number one, or the first one on here, we have a triangle, and we know that angle 1, I can label these angle 1, angle 2, angle 3, doesn't matter how I label them, but all three of these added together equal 180. So angle 1 plus angle 2 plus angle 3 equal 180. Now we also found out though that that is the triangle sum theorem. Okay, so I can take 30 and 75. Okay, and I can subtract it from 180. Now I'm doing this backwards, it's gonna give me a negative, but it's just easier than putting in 180 minus those. It's still gonna give me the right answer. I added those together, subtracted, but I already knew that one, so I didn't really have to do that. But to find n, I can do one of two things. Sorry, this is gonna be a little jumbly because I'm actually, it's not gonna work very well. Trying to charge this stupid phone while I do this. Let me try this, okay. 75, this angle, and this angle together equal 180. So one way I can do this one is because I see they're supplementary, they form this line, I can do 180 minus 75. I think that's right, 180 minus 75. And I get 105, so this answer is 105. Another way I can do it, if I remembered my external angles theory, I could really just add 75 and 30. 75 plus 30 also gives me this exterior angle, because the sum of the two remote, the furthest away from the exterior, the furthest away, not the adjacent, these two added together equal that, or I can subtract from 180 because these two are supplementary. So either way works. Now let's look at this one. Circle the 3 that are true. And I'm so proud, I only had, I think, 2 students out of everybody that showed me this answer that only had 1 circled. All right, so let's look, 3 and 1. First thing I'm gonna do, X, X, O, O, X, X, O, O. All right, that way I can see which ones are gonna be congruent, which ones are gonna be supplementary. So this one says that 3 and 1 are supplementary. Well, I see that they are vertical because they're equal. They're both O's. 1 and 3 are vertical, so that one's not true. Okay? Angles 1 and 7 are congruent. All right, let's look at 1. I already highlighted 1. And 7. Well, this is an O, this is an X. So they are not congruent. And I can also see that this is above my parallel, this is below my parallel, so they're not corresponding. They're not interior, the ones all exterior, one's interior, so there's not a pair, it's not a pair I know. Okay, now angles 7 and 8. So here's 7 and here's 8. It says that 7 and 8 form a linear pair, and that's true, they form this line. So that one's true. Angles 2 and 6 are congruent. 2 is an X, 6 is an X. So yes, that one's true. Okay, angles 3 and 4. So here's 3, where's 4? Oh, 4 is right next to it. It says they're supplementary, supplementary, which means they make a linear pair, they form a line, and that is true. Okay, so on the test, you'll have something like that. But we're taking this on the computer, so it's going to be drag and drop and all those technical kind of questions, technology enhanced questions. All right, let's look at this one. Now, I'm still going to do X, X, O, O, X, X, O, O, because I need to know if this expression and this expression are equivalent or supplementary. If they're equivalent, if they're congruent, if they're the same angle, I just set them equal to each other to solve. But if they're not, if they're supplementary, remember x equals x, O equals O, and then x plus O are supplementary, and they equal 180. So this one is an x, this one is an O. So I'm going to add them together. So it's going to be x plus 36 plus 2x plus 24 equals 180 because of this. Angle 1, angle 2, angle 3. Nope, that's not it. I'm not doing a triangle. Because these two are supplementary. These two added together equal 180. Now I just do what I know about equations. I'm going to combine my like terms. I see an x and an x, so 2, they're all positive here, so 2x and 1x is 3x. I'm going to add 36 plus 24. That gives me 60, okay, because these two are positive and they are constant, so they're like terms. Now I have this simplified equals 180. Now I know to get 3x by itself, I'm going to subtract 60 from both sides. We've already tested on this. We know how to do our equations. This cancels out, so 3x, I'm going to divide both sides by 3. X equals 40, because 3 goes into 12 4 times, and I add my 0. So my answer here was 40. That's all it asked. All right? Now, if these had been an x and an x, or an O and an O, I wouldn't have added it and put it equal to 180. I would have just put them together. I would have gone 2. So let's say I did this one, and I had one over here, 4x plus 21. If it was these two, I would do, because this is an x and this is an x, I would have done 4x plus 21 equals x plus 36. Then I'd move this x over here, move my 21 over here, and I'd get my answer. So when we're looking at parallel lines, we have to decide if they're equal or supplementary. So we're either going to set them equal to each other and work it out, or add them together, set it equal to 180. All right, here's some more parallel lines. These have all the numbers. I'm going to say this is 6. It kind of looks like an 8. Corresponding angles. All right, so I'm going to look up here and see which ones are corresponding. Corresponding means they're on the same side. Same location. So if one's on top of the parallel line, the other one's going to be on top of. You see, 2 is and 6 is, okay? 2 is to the left of the transversal and 6 is to the left of the transversal. So 2 and 6 are corresponding. Okay? Same side interior. Okay, I've got 2 interiors. This is an interior, but this one is an exterior, and this is exterior. Oh no, sorry, this is interior for these two lines. This is exterior for these two lines. So this is an interior, and this is an interior, but it's also exterior for these lines. So let's look. So I need same size interior. So they have to either be in green or pink. I don't have 2 on the same side in pink, so it has to be 8 and 9. Same side interior. Because see, I've got 2 sets of parallel lines. Here's one and here's one. So alternate interior, okay, they got to be either on pink or on green, and they have to be alternate. Well, we know these are same side, 4 and 6 are alternate. Vertical, I have one here, 2 and 4. But I also have another one, 6 and 8. So the 2 possibilities there. Either one would be right. Alternate exterior angles. So they have to both be on an exterior. Green is exterior. So I have a 1 and a 2, and I have an 8. 9 is also exterior, but it's on it's really on the interior of these 2 lines. 8 is exterior of the pink. So it'd be 2 and 8. 2 is on the exterior, 8's on the exterior, and they're alternating. This is on the left, that's on the right. So 2 and 8. Those will be their answers there. Okay? So you've got to make sure you're looking at the right interiors and exteriors when you have more than one diagonal. Okay, this is new. We've not really looked at a parallelogram. This says that this line is parallel to this line. We also know that these two sides are also parallel because a parallel has two sets of parallel lines. And we have two sets of transversals. Okay? Because this is, the only thing we really know in a parallel is alternate interior. So this is the interior, and this is the interior. All right, so the only things we know is if I look at 42, it says what other angle is 42? Well, this is my parallel. 42 is an interior. D is interior, and they're on opposite sides. So they're going to be congruent. So D is 42. Okay? Now it says what's the measure of angle A? So there's A. 63 is the alternate interior. 63 degrees. What's the measure of angle F? Angle F. So, well, I know D is 42. It already tells me this is 28. So because of exterior angle theory, I can add 28 plus 42 and get 70. So F is 70. Now, if I didn't remember that, I could do 28 and 42 would be 70, and I could subtract it from 180 minus 70 and get 110. I would be 110, and then I know that I and F are supplementary, so F would be 70. So a couple ways you can find F. When we have that parallelogram, the only thing we really know is our alternate interior. Okay, and I'm not going to tell you why. Well, the reason is if we have this line and this one, this is cutting this angle. So this is vertical and this is vertical. And we do know these two are vertical. But this A would not be vertical to anything else. Okay, so this line kind of messes us up a little bit. So all we really know are the interior, alternate interior. All right, let's look at this one. What is the measure of angle 3? Well, I have a 3 and a 4. These are supplementary, but I don't know either one. So I've got to find these two. So I know that 180 minus 92 is going to give me 88, okay, because these two are supplementary. 92 plus 88 give me 180. Then this one, these two are going to be supplementary because this angle and this angle form 180. So 180 minus 123. So 2 is going to be 57. Now that I have 88 and 57, I can add those together. That gives me 4, which is 145. To get 3, I just take 180 minus 145, and I get 35 degrees. Okay, so sometimes you're going to have to use what you know, what they give you to find especially if you see a triangle, because once we have 2 of a triangle, we can find the third and the exterior. Remember, if I was looking for this exterior, I would add 3 and 2. If I was looking for this exterior, I would have added 1 and 3. It's the remote interior, the furthest away from those different exteriors. All right, let's move on to the rest. Okay, here it says the above triangles are similar. This triangle, so triangle ABC and triangle DEF are similar. That means all the angles inside are the same. It also means that the sides are proportional. In a triangle ABC, A is 61. So A is 61. Triangle DEF, F is 29. Now, I know in a triangle, they're lettered. Their name is important. This goes A, B, C. This goes D, E, F. So A and D are the same. B and E are the same, and C and F are the same. And let's check that out because B is 90, E is 90. Yep. If A is 61, D is 61. If C, oh, I don't know C. Oh, let's look over here. C would be the same as F. We know F is 29, so C would be 29. So D, 61, C is 29 degrees. Okay, this problem, we've not really seen one like this before, or we have, but we haven't really worked it. So this is one problem. The other side is a whole different one. Not really a highlighter, but. And then this side is different. Okay? Because all of our properties are going to be the same over here and the same over here. I still have my X and my O. Oh, X, O. X, X, O, O. X, X, O, O. And I have X's and O's over here. The thing is, this X doesn't equal that X because our transversals are different. Okay, if our transversals, well, were parallel, then we'd have all 90 degrees, but they're not. So we can only look at this side and this side. Okay, let's see, X, X, O, O, X, X, O, O. X, X, O, O. And if you'll notice, this should be 11 and 12 here. I just did that wrong. 11, 12, 13, 14, 15, 16. Okay. 9, 10, 11, 12, 13, 14. Yeah, that's how I did it. All right, so angle 1 up here. Looking for angle 1, 12, and 16. It tells us that 5 is 70. Right here is 70. And 7 right here is 120. That's all we need to know to find all the other angles. Because remember, when you have two parallel lines cut by one transversal, there's only two angles in this whole thing because all our X's are the same, all our O's are the same. So if my X is 120, no, that's my O. My O is 120, my X is going to be a linear pair. It's going to be a supplementary. 120 plus 60 equals 180. So that means all of these are 120. All my X's are 120. Wait. Now my O's are 60. So 16 is going to be an O. So O's are 60. Okay, over here, 7, we said, oh. Okay, so 12 and 1 are on this side. So this is 70. That means this is an O. That means this X is 110 because those equal 180. So all my X's are 110. 1 is an X, so that's 110. 12 is an X. Wait a minute, that's not right, is it? XX, XX, XX. Ooh, so 12 would be 110. But I had those mixed up. Anyway, if you have the paper where it says 13, 14, we'll get that fixed. Because if you had, there wouldn't have been a 12. Anyway, we'll get that fixed. It will be right on the test. Okay, 2 more. Here. Now here we have 2 parallel, 2 transversals, but look, we have a triangle. What we're trying to do is prove that do a proof that these are parallel, okay? And because they're parallel, we know that 1, 6, and 5 are a supplementary. 1, 5, and 6 are 180 because they're supplementary. Okay? That's because of the parallel lines. Now, we can use that to prove that all 3 of these inside the triangle are going to be equal well, not equal, all these inside will equal 180. So we already have 6, and 6 is part of our triangle. So 5 would equal 7, because 5 and 7 are our alternate interior. Okay, 6 we already have. 1, okay, 1 would equal 12, 1 and 12, because 1 and 12 are alternate interior of this transversal. Okay, and we know that 1, 6, and 5. So now we know that 1 equals 12, 5 equals 7, and 6 equals 6. So we can say that angles 6, 7, and 12 are also 180 because they are equal to the 3 here. Does that make sense? We're trying to prove that 1, 6, and 5, well, we know that 1, 6, and 5 are 180 because they form a line. We're using 1, 6, and 5 to find congruent or equal angles to those 3 to show that the 3 angles inside are 180. We have no numbers, just numbers of angles. So 1, 5, and 6 we know equal 180, and we already have 6 inside. 5 and 7 are alternate, so the 7 is equal to 5. The 1 is equal to 12. So 6, 12, and 7 equal 180, like 1, 6, and 5. Hope that makes sense. Last one. Now this one, you are going to have a question like this that has no pictures. But guess what? You can draw pictures. Now that we're taking the test on the computer, but you're also going to have paper so you can draw. Okay, first thing I would do when I had to get my paper is I would do a set of parallel lines and go ahead and do this to help me remember to do my X's and O's. I may do a triangle. Well, now here I would do X plus X, or X equals X, O equals O, X plus O equals 180 to help me remember when I do my equations. That's what I need to know. With my triangles, I need to know angle 1, angle 2 plus angle 3 equals 180. All right. I could also do 1, 2, 3, 4. Angle 1 plus angle 2 equals angle 4 with the exterior angle theorem. All right. So triangle A is a right triangle. So let me go ahead and write a right triangle. And it has a right angle. And it has another acute angle that measures 75. Okay, then I'm going to draw another one. This is A, this is B. Have a right angle. And this one has an acute angle that's 15. Okay, so if this is 75 and this is 15, and this is 15 and this is 75, all right, let's see if those equal 180. So 90 plus 75 equals 165. Now if I take 180 and I subtract 165, I get 15. So that means if I have a 90 and a 75, then my other angle is 15. Over here, I had a 90 and a 15, and so they have to be similar because that's the only 3 numbers that are going to add up to 180. So the triangle are not similar because I didn't change that number. Okay, it's not that one. Triangles are similar because they each have a right angle. Well, yes, they do. But look, I can have a right angle that looks like this. And I can have a right angle that looks like this. Just because they have a right angle doesn't mean they're similar. So that's not true. It is not possible to determine whether the triangles are similar from the information given. Well, that's not true because when I just had 2 angles, I found the other one and it's going to be the same as this. So D has to be our answer. The triangles are similar because they each have angles that measure 90, 75, and 15. All right, so if you know how to do, if you understand the front, well, I don't have the front with me. I did that video yesterday, and you understand these on the back, you're good to go.